So here we're looking at some implicit differentiation examples. So we're going to differentiate this function for part A, or actually it's a relationship. So for part A, what we need to do is differentiate each part. So we're looking for the differential of this, differential for this, and the differential for this with respect to x, because we've got the dx on the bottom here. So this is going to give me 6x when I differentiate this. I differentiate this with respect to x, and it's just differentiating the y part, so it becomes 4y, but we add on this dy by dx in here. And then when I differentiate 11 with respect to x, that comes out as 0. So now I'm going to rearrange this and make it dy by dx, and that equals, take away -6 from both sides, divide both sides by 4y, and let's just simplify that. That becomes -3x divided by 2y. So nice and straightforward so far. Now it says find the gradients of the graph when x equals 1 for the next part. So as dy by dx equals an x and a y, I need an x value, which is 1, but I also need a y value. So I need to go back up to here, and I need to find out what my y value is. So x is 1, so it becomes 3 times 1 squared, so that's quite easy, plus 2y squared equals 11. So let me rearrange this, and it's going to give me y squared. Take away 3 from both sides is 8. Divide by 2 is 4. So if I square root that, y is plus and minus 2. So it does say gradient, so it's giving me a hint there that there's probably 2 answers. So just carrying on with B now. When x equals 1 and y equals positive 2, then my gradient dy by dx is -3 divided by 4. So I've just substituted those into here. And there's a second answer. So the second answer would be to substitute in where x equals 1 and y equals -2. And so that gives me -3 divided by -4. So this one gives me 3/4. Okay, so I've got these 2 possible gradients. Now, find 2 possible equations of tangents. So the first one, I'm going to say that y is -3/4 of x plus c. And I got this gradient using these first 2 coordinates. So I'll put 2 into there. -3/4 plus c, and you can see that I'm just going to add the 3/4 onto both sides, plus c there. So I get y equals, the c value will be 11/4, take away 3/4 of x. So there's my first equation. My second equation, y equals, and I'm using these coordinates here, 1 and -2 and 3/4. So 3/4 add c, and this time I'm making my y value -2. So for this one I have 3/4 of x, and the c value, taking 3/4 away from both sides, is -11/4. So that's pretty much as I did before, but I've got these 2 values because I've substituted in the x and got the 2 values here. And we're using the implicit differentiation.